All right, so welcome to TIBCO. This is normally our cafeteria. It's usually a lot noisier, and there's usually a lot more tables. But welcome to TIBCO. For those of you that may not have heard of TIBCO that often, we're an enterprise software company primarily focused on integration and analytics. So we have a number of products in those space. One of the products that we offer, newer product of ours, is actually based on the Golang technology. So these fine gentlemen over here are going to tell you a little bit about that, some of the experiences that they have around it. So again, welcome. Glad you can make it out. Have fun. Lots of food in the back for afterwards. And I guess you guys are up first. Awesome. Okay, so we got Miguel and Leon. Leon has a nickname. It's you may want to know it. I'm not sure if I should say it.
You know what? Just go ahead. Just do it. Just do it.
So he's known as the Mighty Mango. And if you want to know why, you ask him later. I can't really say it on camera.
Oh, thank you. That segued right into my next point, which is please note that this session is being recorded. So your questions will also be recorded, just FYI. At the end of this, if you'd like to take questions, then you will raise your hand, or we'll walk up to you so that the recording can pick up your question, because it is being recorded. All right, Miguel and Leon, round of applause.
Wait, Cassandra, are there a couple
what else did I
What? Do people want to, before?
Nope, we'll do that after.
Got it, okay.
Okay, now, one more time. This is clap.
Does it? Okay, good. Then I'm guessing that mine works as well. Dude, you forgot our introduction. Okay, so even though Cassandra did an amazing job at introducing us. So my name is Daniel Stichter. I'm a developer advocate here at TIBCO, and I'm joined by Miguel Torres, who's going to be the person that actually knows what he's talking about today. So we needed someone that looked nice, someone that actually knows what he's talking about. And at the end, I got asked to substitute. So that just hurts. So before we get started with what is Project Flogo, I just wanted to ask you guys, who has heard about TIBCO before? Who knows some of our products? Okay, there's actually a lot more than I would have anticipated. I saw like 10 hands raised. I would have totally guessed that no one would say yes right now. Yeah, no, I mean we are not that well known, and if you do know us, then you'll likely know us from our Java-based products like BusinessWorks, some of our messaging products like TIBCO Enterprise Message Service, which is obviously based on JMS specification. And while Java is a pretty nice language for the enterprise, it's not that great if you want to run it in IoT-like scenarios. So a few years ago, some of our core engineers who built our process engine around that BusinessWorks technology thought that it would be incredibly useful if we could actually take that core IP of a process engine and take that onto devices. So run it on things like Raspberry Pis, Arduinos, that kind of thing. And in order to do that, you just cannot put a JVM on there. I mean, that's just way too big. And at the same time, Node.js, even though that it is a lot smaller, is still too big. So we started investigating Go, and it turns out that it's actually 10 to 50 times lighter, so we can actually run it on a device. One of the cool things that we added in Flogo is the visual modeling part. And if we have time, we'll actually do a quick demo showing you how you can visually create those microservices, because Flogo is all about creating ultra-light, edge-based microservices so that you can run them on a device. You can actually run them as functions as well. So who of you know Lambda? Okay, I was actually going to be worried if no one stuck up their hand. That was going to be terrible for me at least. So last week at our user conference in San Diego, together with AWS, we actually announced full support for Flogo running on AWS Lambda. So you can now take the exact same flows that you designed, take those microservices and run them as part of Lambda functions. Now the cool part of that is that when you're modeling them, you can actually do step-back debugging. So something that people kind of seem to want to do, at least in IDEs, but you can also now do that visually. Of course, everything event-driven, super fun. But for a company like TIBCO, the biggest change for us was that it's 100% open source. So we obviously offer support around Project Flogo, that kind of thing, but the core of Project Flogo is complete open source. So you could actually go to flogo.io right now, well, not do it right now, but after the presentations, and download that core runtime engine. So why did we choose Go? Because for us, as an enterprise company, as Nelson said, Java was going to be the obvious choice. I mean, that runs pretty much everywhere, is battle-proven, battle-tested. So why choose Go? Well, obviously, first off, it's ultra-light and embeddable. If we compare the microservices that you can build with Project Flogo as opposed to something in Java, then it is at least 10 to 50 times lighter, doing the exact same thing. Now, it runs on most devices, ranging from, for example, the MacBook here, up to M0 chips. It's a great start for serverless, and I like to think that it's fun all around. I mean, Go has the amazingly cute Gopher. I think it is cute. I mean, we obviously have the incredibly cute hummingbird that you just saw on the screen. And with the entire community, with a lot of you guys here, we make it fun. So I talked about how small it is, and I just wanted to illustrate this a bit. So a typical Java microservice runs at about 180 megabytes, just starting it up, doing a few bits and pieces. Same service, Node.js, around 74 megabytes. The exact same thing in Flogo takes 3 megabytes of RAM. So that would actually run on a Nest thermostat, would run in your Toyota Prius, not saying that we embed our software there. Will be cool though. And the other thing is that, as I mentioned, we can run on microcontrollers, so we can actually compile down up to 50 KBs. Now, I have to admit, since a lot of you people know Go probably a lot better than I do, that as you do that, we actually transform it into C. So the super small stuff, that's actually C embedded on your microchip. So Flogo has been rapidly evolving over the last 6 months, starting from device profiles, where you can actually run on super small machines, up to things like flows as functions running on AWS Lambda, and machine learning with Google Tensorflow. So we have full support for Google Tensorflow, so you can actually take your models, run them in Flogo, so that you can actually make smart microservices on the edge on your Nest thermostat, for example. So that was all cool, but we needed to make a few changes. And one of the biggest changes that we had to do is change the way that we do dependency management. So Miguel, up to you, buddy.
Thank you. Can you hear me all? Okay, so yeah, just a little bit of pure Golang now. So basically, just a little bit of background on what we were trying to do when we thought about creating Flogo. Basically, it's going to be an app that you can compile and run anywhere. So basically, you have some objectives. The first thing that we wanted is so people that don't know Go to be able to like build and run those programs. We also want a way to like easy add and remove packages. So we have some dependency injection in the init files that gets loaded. It's basically like a registry. We also wanted some vendor support, which, yeah, since 1.5, that's a thing. And then the last bit that we were waiting for was this dependency management support. And obviously, you want to build an app. So at the beginning, we started with GB. I don't know how many people have used GB here. It's basically a builder tool that pretty much does everything that our objectives had, but it does it in a very non-ideal way. So basically, the few problems that we were having is that the package structure that GB creates is not standard Go. So you can only build that Go using the GB tool, and that creates some like friction if you want to like bring it somewhere else and then do some other stuff. So that was okay, but we could have lived with that. The biggest pain that we had was that it's not ideal for complex builds, especially for different build modes. As you know, you can just do go build and pass build modes to actually create different type of executables. Then, for instance, like plugins, and you can have share links and stuff like that. So that, and the last one, which was the second factor, was that it's not ideal for dependency management. It has some built-in there, but it's not ideal. It has some plugin mechanisms, but we found it like pretty clumsy. Even though it's a great curve. So basically, the changes that we did was to for different objectives. For the package abstraction, we were doing manual, a little bit of manual and GB. We changed it to just the manual, a few files creation, and then wrapping the Go path. So basically, when you do the flow Go CLI, you just, during the command, you can pass the environment in there. So you can actually say that your current directory is the Go path. So then the rest, you can just call Go path in that command executable. And then the rest is basically Go dep. Go dep takes care of adding and removing packages. So you have a dep ensure -add, and that will actually allow you to add constraints to it. We'll see an example of a manifest, or what they call a manifest. It's a dumbbell file. Then you have vendor support. When you go to Go dep, you give away control of the vendor directory, which is great in my opinion. But it has its downsides as well. But what you're basically managing is two manifest, one manifest and one log file. With those two, if you have the constraints and the logs, then the vendor directory is created for you. And then the dependency management is done for you, and then the build app, we change it from GB to actually Go build. So that allows us to create a more standard builds with all the power of the actual Go build. So what is the Golang dep? Is the official experiment. It hasn't been added to the main repo, but it's the official experiment. So during the path to change, we found a couple of things that caught our attention, which we want to share with you. So basically, what's the difference between dep ensure and go get? So the go get, as we all know, which just gets the latest in your source file, in your go path source directory. While ensure, what it does, it's just synchronizing the manifest and the log and the vendor directory. So basically, you are managing your dependencies through manifest files, and they give you the CLI for managing those files. And then you just, during ensure, it just synchronizes everything. Then there is an interesting thing that you immediately think about. It's like, what about the dependencies of your dependencies? So there are direct dependencies, which are the ones that you are directly importing in your packages. And then you have transitive dependencies, which are dependencies that are added by your third party. So if you really want to constrain those transitive dependencies, which can get pretty tricky, you have two options. Either you bring it, you make it your own project dependency, so that your constraints are dictating those dependencies, or you can use overrides. They say to handle overrides with care because it's really powerful. So some of the differences that you have is like the constraints can be declared by any project. So if you have a constraint in your project and then you're depending on project B, the project B the constraints will be taken into account. However, if you're overriding, only the ones that are declaring your project will be taken into account. The rest will be ignored. The constraints apply to your direct dependencies, while the overrides apply globally to all the projects. And one of the biggest differences is that your constraints must not conflict with other dependencies. So if you have a dependency conflict, it will throw an error. While the overrides, it supersedes any constraints declared in all the rest of the projects. And the second big thing that caught my attention is, okay, So it feels a little bit of magic when you actually do the ensure. It just brings down all these dependencies and puts them in your vendor directory. So there are actually some rules in their libraries where they sort the dependencies depending on some rules. So I'll outline here the rules of like how the versions are picked when you do ensure update. So basically, yeah, the first ones are the server versions. Then with a little bit of an exception, the pre-release goes after the non-pre-release. Then default branches, semantic versions, by the way. And then revisions event. So that's an example of what the order will be. How are we doing time? Are we good? So that's project dependencies management, which is a hard problem. So it's good that somebody else is taking care of it. But yeah, it's very easy to use, and it's awesome. Should I go ahead?
Actually, let's ask the audience a question first. We have about 8-9 minutes, if I understood Cassandra correctly. Okay. So we can do two things. By show of hands, do we want slides or demo? Who's up for slides? Okay. Good. Who's up for demo? Oh, nice. There is someone super excited over there.
Okay. Yeah, that's what we thought.
Yeah.
So I hate slides too. So basically, the demo is going to be a simple one. We're going to have a flow that is going to be called by 3 triggers. Just a little bit of background. So our applications can have multiple flows, and those flows can be called by different triggers. So it's basically a trigger action, where the action is the flow. So what we have is the same flow, that is just a hello world flow. It just logs a message and replies. But the interesting part is that you can build, without touching the flow or anything, you can build it to do 3 different things. One for each of the triggers. One is going to be an HTTP trigger, where you can call and it will do the hello world through a URL. The second one is going to be through a CLI. So you just do a command and it will return. And the third one will be a Lambda function. So we can show a little bit how all this work. Is this big enough? A little bigger?
Yeah.
Is that cool? Yeah. Okay, so the first thing we're going to do is like build a flow from scratch. Actually, let me show you the configuration. Oh yeah, it's visible. Okay, so basically, this is our JSON file, which is the configuration that defines the flow. So you can actually build it from scratch, or you can build it using our UI. Here, you have an option to export it, but bottom line, it has all the metadata that our engine needs to run the flows and lifecycle the triggers. So what we're going to do is like first creating the flow. Normally you would only need this, but I'm just going to show as well that you can actually use what we talked about to manage dependencies. We're wrapping the go dep command to pass dependencies. So we're adding a master here for this library, and we are adding the master for this other library. So we execute the command, we read the JSON file, we look for the dependencies, and then we create 2 main files, two files in the main package. And then we just run go ensure. We can actually show how that looks. Well, better here. So if we do the trigger, we have like a normal goal and package structure. We have the flow.json, which is our metadata. And then if you see the SRC and then our app, this is what we talked about. This is the actual manifest for the dependency management and these 2 main files, which is when we are doing the build, we just put whatever files with the dependencies that we want and we run go ensure. And it will pick everything up for you. So we don't have to worry about adding or removing manually, only if you want to add constraints. So basically, let's keep going with the demo. So now we're just going to build first the HTTP trigger.
So essentially all the steps that Miguel is doing from command line, you can do from that same UI as well. So rather than making all those curly braces match up, you could actually do that through the web UI.
Yeah, so we built, during doing Flogo build, we just built the actual application, and then we just go to bin directory and we execute. And what we have is an HTTP trigger listening to our that port, and my name here. So we have the hello world, which returns hello, and then it runs this activity, which is just a log. So that's the first use case for the application, that it runs as a node, that it has an HTTP server listening. The second one is to actually run it or build it as a shim. So shim, and then during the shim we can give it the actual ID of whichever trigger we want to build, and in this case we're going to do it as a CLI. So if we build it as a CLI, we have the same executable, but now when we run it, it just runs as a CLI command. And it goes, runs the flow, and comes back. So this is the actual log that we had before, and this is just the returns. And then there is a third one, which we wanted to show, which is the actual Lambda. So you just run it in there. So we're using a Lambda Go Shim open source application, framework that builds the shim, because the problem is that Lambda doesn't have Golang support just yet. They're promising that they will be, but we don't know when that's going to happen. So there's a library called AWS Lambda Go Shim that does that wrapping for you. It creates some Python middleware that will run the application for you. So you just have to implement some interfaces. And basically what we do is like, we have this handler.zip, and basically, well, I created one just for use of time. I uploaded it, and then you can just run this application as a function in Lambda. So then we have the same executable, the whole flow running in a Lambda function.
And that, sorry to interrupt you there, Miguel, but that was one of the most important things that that we set out to create when we created Flogo, is that you could actually take the exact same flow, run it on a device as small as a Raspberry Pi, and then even smaller, that you could run it as a CLI, so you could actually build your CLI programs using Flogo, or that you could run it inside of Lambda using their constructs. So no matter what you choose, you could actually do everything with Flogo.
Yeah, just to finish up, just a little bit about how, since we were talking about constraints, this is the command that we added, where you can add a branch, you can add a version or anything else. The override will be here. And then the log file is the one that locks your actual version and revision number out of those constraints, following the algorithm and the rules that we presented before. And that was all.
So if you have any suggestions for us, then we would obviously love to hear that. Go to flogo.io, tweet us with @FlynnFlogo. Flynn is the name of the cute little hummingbird. Or create issues on our GitHub repos, and either me or Miguel or the rest of our engineering team would be more than happy to answer all of your questions.
Where do they get Flogo at?
That's a good question. We did not show that. Thank you. So I'm sure that everyone, especially the back, can totally read the URL here on my T-shirt, or we could totally show that on your Mac real quick. So you just go to flogo.io.
They're smart. They know how to do it. Flogo online. No, yeah, we have. It's important to see. We have 3 different repos. The one that is Flogo. So this is the page, GitHub. So this is the main one that only has the documentation and a few of the issues and all that. And then we have 4 different projects. The CLI is the one that you've just seen, which is the one that allows you to like build and create different projects. The lib is kind of like the engine, the back end of it. And you have services, which is it's for the UI to do some testing and things. And then the contrib is the one that has the triggers and the actions and everything that you can contribute to. So let's say instead of having an activity here that is a log, you might want to do something else. So we have a bunch of activities there already. That's all sort of stuff. We have Lambda, we have Counter, Couchbase, HTTP, REST, Twilio. So basically you can have your own logic there, and then you just release it. You just implement a couple of interface, and then you're good to go. You can run it. Yeah.
If you do end up building something cool, we would love to know that too.
Yep.
All right. One or two questions, first answers. 1, 2, 3. Questions? 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 No? Okay. No second chances here. Thank you. Conrad, you're welcome to get set up. Okay. The next thing we're going to do has been in high demand. If you're hiring, please stand. Yes, we're going to put you on the spot. Okay, I'm going to come to you first and say a little bit about what you do, what you're hiring for, who you work for, and you have 30 seconds.
I'm Bill. I work for Nest. We're hiring site reliability engineers and DevOps people. Go is one of the languages we use for our tooling. And our office is about a half mile up the road. And we're part of Alphabet, so it's Google benefits.
I learned all about Alphabet and orientation on Monday. Benefits are nice.
Thank you. Hi, I'm Paul. I'm an investor in a Bitcoin exchange called Rain. We're looking for a lead engineer who's interested in Go and Bitcoin or blockchain technologies. So if you're interested, hit me up or email aj@rainbtc.com.
Awesome, thank you.
Hi, I'm Andy Jackson with ChargePoint, the EV charging company, and we're hiring software engineers for our main cloud platform, and we primarily use Go.
Oh, this is so popular.
I'll jump on the EV train. So my name is Thomas. I work for Tesla. We're across the street pretty much, and we are hiring a lot of backend engineer working on Go apps.
Hey, Tesla. Is that a Go bunch yourself shirt? You know, those will never exist ever again. You and I have one. Very few people do. I'm sorry, what was your announcement?
My name is Ethan Khan. I am a co-founder of a company called Mode Inc. We're in San Antonio. We are a solution provider for IoT in enterprises and manufacturing. And we use Go in backend, in servers, and also in devices, in like basically Raspberry Pi and OpenWRT and what else? Basically, yeah, tiny footprints, devices. So if you're interested in building or running Go in actual devices as well, like basically super full stack, like from front end to back end to the edge. Tom?
Thank you. I'm guessing you work for Netflix, Scott?
Walking billboard, yeah.
Yeah, okay.
Okay. Hi, I'm Scott Mansfield. I work on the cloud database engineering group in Netflix, and my team works on EV Cache and Dynamite. They're two open source caching solutions for the cloud. We also have another internal project still that's a distributed data storage system. We use Go primarily in EV Cache server side, but our team also does work in Java, and C, and C++, and Python. So we're not like strictly a Go team, but we are looking for a senior software engineer. If you like high scale, if you like low latency, if you want to work with Netflix, then come talk to me.
Cool beans. Last one.
So I'm Walter Vanini. I'm with a small startup called Scaled Inference. We're roughly 20 people, and we're hiring all over. There's machine learning experts, systems people, DevOps, and our infrastructure is, our backend certainly is all in Go.
What does it do?
Yeah,
what is scaled inference?
Scaled Inference is currently in stealth mode, and ready to launch soon.
I love that's the best answer ever.
We want to bring artificial intelligence to the masses,
Right.
make it very easy to use.
Rad. That's hot. Okay, that's it. That's what you get. I also recommend that if you are really looking and you are seriously looking, then you're welcome to post on our meetup page, which I think is around 4,500 members. It'll pop up as something as active as happened. You can do it under this particular meetup. So that's just a little tip. Thank you for waiting. I know, not everyone has to wait that long. You're just standing here. All right, round of applause for Conrad, please.
Hey, it's good to be here. Has anyone by any chance been to the Golang UK conference this year? This is good because this is basically an upcycled version of this talk, so you should all hear something new now. Yeah, my name is Conrad. I work for a startup here on the peninsula, and I will talk today about WebSockets in Go. I'll also talk about REST, APIs in general, but in particular about architecture. So for us Go developers, building and maintaining APIs is pretty much our bread and butter, right? And you can't mention APIs without mentioning REST these days. And that is mostly due to the fact that it's been around for 17 years and it's still highly relevant. And the question is really, why is that? I mean, for one, it helped to evolve the web and web applications in general, because it decoupled server and client communication, at least the implementation part, and it gave us a standardized way of communicating between services, because if you were able to speak HTTP, you were able to, or you are able to communicate with RESTful services. So the question is, though, what is REST? And I'm asking this question because for me personally, I always thought, well, obviously you have on the left side HTTP methods, these HTTP verbs, right, like get, post, delete, and you're supposed to map them to resources. So if I specify what should happen if I receive an HTTP delete request, which is targeting a certain resource, then depending on what should happen, for instance, marking the database entry as deleted at, then that's obviously implementing a REST API. Well, it turns out there's a little bit more to REST. REST is actually not a technical implementation. Using HTTP REST is actually an architectural pattern which was developed by Roy T. Fielding in his dissertation. And what he did basically, he said, well, REST is a set of constraints which build on top of each other. And the first constraint is client and server. So you don't want to mix up the user interface with the server. Then the connection should be stateless, right? Every request should contain all the information in order to give a response. Responses should be cacheable. And then we have the uniform interface. And the uniform interface in the case of HTTP are just using or making use of these HTTP methods. But that doesn't mean that it could be something entirely else. And then we have a layered system, which is a general property over all of these constraints, and code on demand, which doesn't really have too relevant implications anymore these days. So But this has been 17 years ago, and a lot of things have changed since then. And just to make one thing clear here, this is not about like bashing REST, like REST is the past, you go and use WebSocket. This is not the point. I want to make a much more fundamental point about architecture, but it still helps to see in what direction everything is developing. So with HTTP 1.1, actually, we got persistent connections, which is kind of a big deal, or was a big deal back then, because for the first time, it was possible to have more than one request-response pair. And from there onwards, only more technologies were added, which enabled us to actually have real-time applications. We got Ajax, we got WebSockets, which back then still had a pretty poor implementation in browsers, and you had to fall back to polling solutions. But this is all in the past now. The WebSocket API is fully developed on all browsers, and you can make full use of its features. And then a couple of years ago, React started to become a thing, like using completely new ways of rendering live data. We got other concepts to use APIs, for instance with GraphQL, a much more declarative approach. And by the end of last year, we had a really high React adoption. And that means going forward, not including a certain real-time component is probably not going to happen, especially if you are in the space of developing applications. Now, WebSockets, I think, also, at least from my perspective, have a little bit of an image problem, because when I thought about WebSockets in the past, it was, so why should I use WebSockets? You could use WebSockets if, I don't know, if you want to implement a chat, right? That's like a classical thing, or games, like you have the live action real component, so everything needs to be up to date. But I think this is really missing a fundamental point about WebSockets. And that is synchronization. Like, it's impossible these days that you have an app which only runs on your phone. Usually you also have it on your desktop computer. Maybe you have something running on your watch. App state, notifications, and all of these applications are fighting for our constant attention. So what happens if you receive a notification on your phone and you swipe it away? You have it still open on your desktop computer, and you still see that notification there. Why do you need to like click on the notification just to see that it was the very same notification you just dismissed? And this should be really the point, because in a classical polling architecture, the client would always need to ask for updates, even though the state change happens on the back end. So why shouldn't the back end or your infrastructure be able to push these changes directly to the clients where they could receive the updates immediately? So WebSocket is a message-oriented protocol, and it gives us a bidirectional communication channel between server and clients. So the server can read messages, the server can write messages, and so can the client. So in a way, they're almost indistinguishable. Messages are split into frames. WebSocket supports fragmentation, which is important because it allows us even to send data-heavy payload down. And the payload can be binary or text, which gives us a really good compression properties. So how does this whole thing look like in Go? In the Golang UK talk, I was still talking about other WebSocket libraries, but the problem is I actually started showing libraries I wouldn't advise to use, and chances are you will only remember the first thing, so we will jump straight into this, and I will tell you if there's really a WebSocket library and you don't have two special requirements, there's really the Gorilla WebSocket library you should go with. Because even in the standard library for the Golang project, they advise to use the Gorilla WebSocket library instead. And there's actually even an ongoing discussion about adopting the Gorilla WebSocket library into the Golang stack because the maintainer offered to donate it. So this is definitely something which is going to happen sooner or later. So with the Gorilla WebSocket library, how would this all look like in Go code? So it works the following way. What you do is you register an HTTP handle on an endpoint. Here in this case, this would be WebSocket/WebSocket. And what happens is once a client connects over HTTP, you use an upgrader to upgrade the HTTP connection to another protocol. This works because HTTP offers us the possibility to upgrade from one protocol to another one, which in this case would be the WebSocket protocol. And then what you get is a WebSocket connection struct, which allows you to read messages and write. And what you would usually do is you would have basically a reader-writer loop, which takes in messages, processes them, and then sends it possibly down to the client again. So now you might think, or maybe you don't think, I don't know, this all seems very manual. Like, if my application has like real-time requirements, do I really have to write all this boilerplate code myself? Isn't that like a solved problem? There are like tons of services out there which you can use, right? You can sign up with them, you can use them. Seems like they've solved all of these things, and that's true. There are services out like Parse, Firebase, Pusher. These are all data synchronization services which offer off-the-shelf software solutions for this thing. And all too often I get the feeling that it's about shipping products, right? Like, you don't have time, you need to bring a product to market, you don't have time to write all this boilerplate code and write everything from scratch. You need to just cut some corners, right? You need to get it out. And I think this is a bit of a fallacy, because what you really do is you're not skipping, you trade just the cost of implementing it yourself against the cost of integrating all of these services. And what is more, usually these services have a very opinionated data structure, because in order to offer all this flexibility, they also need to limit or narrow themselves down a little bit. And maybe this structure doesn't fit quite your requirements. And what comes to this as well is usually these services have limited querying abilities. And also often, I think companies struggle with like outsourcing exactly these kind of data onto a different service, because maybe it's one of your main business data. And the same is true for sessions. All of those offer session management, but then again, it doesn't mean that you don't get to integrate this. You still need to integrate it, and you still kind of need to take care of the whole authentication and authorization process. There's one upside though, and that is scaling a WebSocket architecture is hard. It's definitely a non-trivial problem, and all of these services offer scalability out of the box. So this is definitely one thing you can set aside. If you know this will grow really fast, then the question is definitely there that this could be a great fit. So how would this look like if we were to move from a polling architecture to a push architecture? So usually you have your clients, they send HTTP requests, these HTTP requests get their responses. And moving to a push architecture, we would set up a WebSocket connection with the client, and the client would subscribe to the API. And once the backend registers a state change, because for instance a client has written something, then that state change could be published over a message bus back to the clients. This is using the classical publish-subscriber pattern, but it could also be different. For instance, you could implement your own RPC framework if you want to, right? You could just send JSON objects which would denote these RPC methods. When you don't like RPC, that's fine. You can also just use a stomp-like protocol. Because the nice thing is, since it's message-oriented, you can decide how these messages should look like. So that's an example of how you could implement, for instance, an RPC framework on top of WebSockets. So our handle connection is attached to a router struct, and that router struct keeps track of different endpoints. All of these endpoints could be one of your RPCs. And in your reader loop, you take care of parsing the message. Then you need to keep track of the writer, because the client which connects to you denotes basically a socket, and that socket is kept open for the whole time this connection is there. And then you can basically figure out to what RPC it belongs and respond to it in that manner. If these requests take a little bit longer to process, or even if you get a lot of concurrent requests, then this would block here, and you would need to wait before you could read new messages. Now, this can be pretty easily solved, as we all know in Go, just adding the Go statement. This is really the most naive solution to add concurrency, but I think I think you should always go with the most easiest solution and then start to measure and figure out where are the bottlenecks and then tailor your concurrency solution to that, then trying to apply patterns you might have seen before somewhere else. Then one thing you will definitely run into when you use the Gorilla WebSocket library, we started introducing concurrency, so writes will also happen concurrently. We will run very quickly into a concurrent write to WebSocket connection. This can be solved pretty easily by adding mutex around writing messages back to the client. There's also an issue on the Gorilla WebSocket library where they're actually discussing whether they should take care of the synchronization. That's a mistake in my opinion, because only you as a consumer know what type of synchronization you want to apply and what really fits your use case. So I think concurrency-wise, it should always be left to the consuming side. Another question I often run into, so you have this WebSocket connection now, and is it actually safe to like send now, when you need to authenticate, send passwords and clear text over WebSockets? Like this doesn't seem really safe. And the answer is, it's really the same as with HTTP as well, right? Like you wouldn't send sensitive information over HTTP. You would want to send it over HTTPS. And we get the same with WebSockets as well. It's just WebSockets have two modes, an unencrypted one, the WS protocol, and an encrypted one, WSS. And the encrypted mode just uses TLS SSL encryption to encrypt all the data which is sent. So this includes even the initial handshake, which is really important. And once that connection is set up, you can just send whatever you want. This brings us also to sessions, because once you're authenticated, you potentially have a session token, a cookie, which you want to reuse. And this is again different to HTTP. HTTP requests are short-lived, right? You send out the request and then you get a response and that's it. So we could do the same with WebSockets as well. We could just include the session cookie in every request. But one big difference is once the WebSocket connection is open, it stays open, so which makes it stateful. And even though many people say, well, statefulness is evil, right? Like it could have side effects. We should really make use of this in this case, because this is what makes WebSockets so powerful. And for that, we could, for instance, simply include the session cookie as part of the query parameter. So the first time a client connects, it could include this into the endpoint. The token could, for instance, be a JWT token. And the advantage of this is the authentication only happens once when the client connects. And this actually has a much stronger protection against cross-site request forgery because it only happens once. And the same applies if you have a unauthenticated connection. The client would simply connect to it without providing it. And then once it logs in and sends the credentials, then this existing WebSocket connection is reused and upgraded to one which is authorized. So in the Go code we've seen before, this could simply be done by reading out the session ID, passing it to our handler, and then picking out the session possibly out of the database and continuing on that. Now, as I said before, scaling WebSocket architecture is a hard thing, and it has definitely other constraints than you would get with HTTP, since the connection stays open. So just think about this example. When you have client 1, and client 1 persists data through server 1, which basically owns the WebSocket connection. And then you have client 2, who will need to learn about an update of client 1, but client 2 is connected to server 2. So how do these two now communicate with each other? It would need to make a whole round trip, or server 1 would need to figure out that client 2 sits on server 2. And this is So the most straightforward solution to scale this out horizontally would be to add a message bus. And you could add a message bus by using the publish-subscribe broker. There are good implementations. You could use Redis, you could use Kafka. And this has the advantage that it would also take care about handling failover, right? One of the server goes down, the client needs to reconnect, and through a load balancer it gets connected to the next server, but the message bus will take care of providing all the data the client needs again. In terms of load balancer, most load balancers were optimized for HTTP, and AWS ELB has actually added additional support, because if you want to use a load balancer for WebSocket, you need to put it into TCP mode. You can't use HTTP, because once the upgrade happens, you're on a pure TCP connection. And what you usually lose there is the information from which client the packets originate. What you have in HTTP is you have the X forwarded for header, which you can read out and then learn from which client this was sent. This is just stripped off with TCP. But since AWS added proxy protocol support, that's actually possible again. And then you have whole other problems, because since the connections are not short-lived, you actually need to keep track of all the sockets you open. And there's a hard limit of sockets you can open per IP address on a machine. So if you want to go beyond these 65K roughly number of sockets, you need to add more virtual IP addresses. And then you need to tweak the file handlers. The maximum number of file descriptors which you can keep open on your machine. And this is all solvable, but it's definitely something you need to figure ahead of time before you want to scale out. So what you usually can do here is use a combination of DNS and software load balancers, which would look roughly like this. You could use the DNS to distribute it to the different load balancers. And the important part, again, is having all of these servers connected through the message bus in order to distribute the messages again over a publish-subscribe pattern to the other servers. There's one other library I would recommend if you definitely want to scale much more beyond, let's say, 60K, 100K, or maybe even 1 million WebSocket connections. There's a WS library. It is an efficient low-level WebSocket library which allows you to reuse I/O buffers between connections and exposes these low-level interfaces. And then they've introduced something they call zero-copy upgrade, because every time you open an HTTP connection, that HTTP connection also allocates memory, which then again needs to be garbage collected. And they skip this step completely by upgrading you directly to the raw net connection. So to recap, basically, I talked about REST in the beginning, and the point really was the talk is not called "It doesn't have to be REST" because you shouldn't go with REST, but more you should try to understand what are the underlying requirements that you are facing. And if you know that real-time updating and keeping your users up to date with notifications is a requirement, WebSockets can be a great way. You can implement what you have with HTTP REST just by using WebSockets as well. It doesn't make any difference. Once you've set up your middleware, it looks transparent to this anyway. So WebSockets allow us to implement a push architecture. And what is more, it gives us the freedom to actually design our own sub-protocol, which is tailored to your system needs. We are not dependent on any service which tells us how the data should look like. And this is not only a thing about connecting browsers with a server. This can be used with anything. You can use this for your mobile applications, but you can also just simply connect your backend components together with WebSockets. And as I said before, it's often considered that rolling your own implementation is considered costly, but I think it's actually quite the opposite. What you do is it doesn't really cost you time, but rather you invest. You invest time into your own stack, and what is more, you invest that time into your team. Because your team will grow and become proficient with the implementation they've chosen. And when the requirements change, and they will change, then your team knows the ins and outs of the implementation, and they can adapt very quickly to those needs. But then again, scaling WebSocket apps or WebSocket architecture in general is a non-trivial thing. You need to plan this in ahead of time. And one thing which is definitely crosses the line with REST is it has bad compatibility to the outside world. This is not something where you would want to necessarily open it up because people would need to adapt your protocol. This is more something you would want to use internally or in connection with your mobile applications. Thank you.
Any questions? Going once, going twice? Oh, very fast. That was a good one.
I have a question regarding the using it for anything else than the browser. What would be the benefit of using it? Once the HTTP2 came out, you can use HTTP2 with any other library for connecting, let's say, services between each other. Like the JRPC recently came out and it was a open source implementation of the same thing before that can run over HTTP2 and things like that. So what would be using WebSockets instead?
So I didn't quite get the question.
So you mentioned that this is not only for the browser. The browser has already the WebSocket capability built in, so your website can receive updates. But you said that it's not necessarily only for that. You can connect your microservices between each other, right? What would be the benefit of doing that instead of using gRPC, let's say?
The advantage
over HTTP2.
Yeah. So I've thought about this as well. I think gRPC has definitely greater capabilities when it comes to connecting microservices with each other, because you get all the support for static compiled languages and you can do the code generation, right? And I've looked into gRPC on JavaScript, and if they would offer the same good support, but that all still seems very experimental, then this would be, in my eyes, a better choice. But this is definitely relies more on the JavaScript side of things, and I think the argument is basically if you've already set up this infrastructure and there's nothing really hindering you from using it between your services as well, but that would only be given that it's already there. If I would do it from scratch and would just want microservices to communicate with each other in a non-published subscriber way, right, where you want to publish to many services at once, then I would go with gRPC.
Okay, are we gonna do that thing? Was that a lot of pressure for you? Or don't you want to do it? I mean, okay, who has a gopher? A gopher plushie. Raise your hand. Okay, who has 2? Who's 3? Okay, who's purple? Really? Me too. So purple's like the most rare. Everyone always wants it. We don't have any plushies for you, but Deets, yo, 2 new colors coming out. Yeah. Oh yeah. Oh, I don't know. I know how many I'm ordering because I just upped that order. But we'll see what happens. But right now we're gonna do the raffle. So stand up. Yeah, because y'all look tired. Stand up. We're gonna do the raffle. Where is it? Come do it. Y'all do it.
But I mean, I'll trade you for a.
Now sit back down. I know that was short-lived. Now sit back down. That was just to get you moving, because you have looked a little stiff in your seat. Okay. Do you want me to pick it and then you announce it?
If you want. Well, yeah, or you can pick whatever you want.
No, I don't want to pick. I do a lot. I don't need to pick it.
But I'll trade you for a Gopher plushie, and we just.
No, I don't have them yet. I haven't even seen them yet. I get to see them on Tuesday for the first time. The colors are good. Sorry, I got excited. It's very exciting.
I know.
It's very exciting.
So.
Okay, the number is
668 6691.
Oh wait, no one went. Wait, where's mine?
Well, that would be hilarious if you'd actually.
It would be so cool. It would feel like. Is it you? Oh, please repeat it.
668 6691.
Was it you? Woo! Come over here.
All right. Nice.
Oh, well, you got a pencil from me too.
Congratulations, sir.
I get really excited.
I'll take that, and then you obviously get that one.
When you're ready.
I believe you.
Wait, okay. Wait, this is yours!
Yeah.
Yay!
Yay.
So exciting! I'm more excited than you are, I think.
Thank you.
They bought it.
Wait, just, can you stand it?
Oh, with me? Oh, okay. Oh, you insist. Awesome.
Congrats.
Woohoo! Yay! Alright, well, this is not a nice way before starting your talk. Everyone got to stand up. People got prizes. We found out there's 2 more Gopher plushie colors coming out. Alright. Round of applause. And I'm going to mess up your name. Otto.
Perfect.
I did it right! Round of applause, please. Yes.
All right, can you guys hear me? Hello? Okay, that's much better. Okay, well, thank you guys so much for coming out tonight, and thank you to Ken and all the organizers, TIBCO, for giving us the space tonight. The talk I want to give you guys tonight is titled Securing Go APIs with JSON Web Tokens. And just a little bit about me. My name is Otto Kukic. I work as a developer evangelist at a company called Auth0, and we're an identity as a service startup. We're starting to use Go in a couple of our projects. We're not quite there yet where we're using it in major production level stuff, but I'm advocating for it hardcore. You can follow me on Twitter at KukicAuto, and then if you have any questions about this talk or Auth0 or anything, feel free to email me at auto@auth0. And we are also hiring. Like I said, we don't have too many Go-specific positions open, but we do have a lot of engineering, DevOps, all kinds of positions like that. So with that said, let's get into the talk. So there's really 2 things that I want to cover in this talk. One, why JSON Web Tokens and Go really go hand in hand together. And 2, some of the lessons learned from building a really big RESTful Go API that I used and protected with JSON Web Tokens. So, how many of you guys have worked with JSON Web Tokens before? Okay, so just a couple of you, but basically what you're looking on the screen is a JSON Web Token, and to everyone in this room, this doesn't mean anything. It's just a signed JSON Web Token that contains all of the interesting data within. We can read it like this, but a JSON Web Token essentially has 3 parts. And I'm using Dexet to create this presentation, and I found out today that it doesn't allow you to highlight text. So I split it up into 3 different sections. They're delimited by a period. So this is the first section of the token. In bold is the second section, the body, and then the signature at the end. But basically, these 3 sections are the header, payload, and signature. So if you're, I'm going to give you a quick abridged introduction to JSON Web Tokens. So what you saw previously was the token itself, and this is the data within it. So the first part, the signature, tells us what type of token it is, and if you're using JSON Web Tokens, of course it's going to be a JSON Web Token. And the second header that you'll see here most of the time is the algorithm of the JSON Web Token, and in this case we use the HS256 symmetrically shared key sign algorithm to sign the token. So that's really not interesting. The really interesting part of the JSON Web Token is its payload, and the payload contains all of the claims and all of the data that you want your token to contain. So this is really the meat of the token and the really interesting part. Now, there are 3 different types of claims you can make. You can make standard claims or reserved claims, as the standard calls them. And these are claims that are defined in this spec for JSON Web Tokens. And they're claims such as the IAT claim, which is the issued at claim, which tells you when this token was generated. Another one of the reserved claims is the subclaim, which is the subject claim, which is basically the ID of the token. And then the other 2 types of claims you can make are private and public claims. Public claims are claims that, again, are registered with the standard, I forget what the agency is that kind of keeps track of them, but these claims are used for interoperability. So if you're if you're building an API, whether it's a RESTful API or a gRPC API, and you want other people to come and use it, you may want to have some standard claims, such as instead of you doing first name for the user's first name, you might use given name for as kind of the established claim. And then finally, the private claims are claims that are specific to your implementation, to your application. And these claims, the example I always give is like the roles or permissions claim. So you might, in your token, say that this user is a super admin, he should have access to everything. Now, for you, that might just be a string that says, role administrator. But for me, I might want to really, narrow down permissions and say, a user that has this token and has the claim of being able to make GET requests can only make GET requests to my API. Or a user that has certain permissions, they can, create data, they can view data, but they can't delete anything. So that's going to look a little bit different. And in a JSON Web Token, you can put essentially any valid JSON data. So it's really up to you how you decide to implement private claims. And then finally, the last part of a JSON Web Token is its signature. And here, again, we're signing this token with the HMAC SHA-256 algorithm, which is a symmetric signing algorithm that takes a shared key. So when you create the token, you give it a string, you give it basically a password. And to verify that that key is correct, you have to have the password again. So when it comes into your backend, you try to decrypt the token and you verify that the password is correct, and if it's not, then the token is invalid. And this was just a very, very brief introduction to what JSON Web Tokens are. If you guys want to learn more, you can check out jwt.io, which is one of the services that we maintain and allow, make it really easy to work with JSON Web Tokens and learn how they work and all of the intricacies of them. But, I mean, I'm a gopher, not a rodent, not a cybersecurity expert, so, I don't know a lot about the different signing algorithms or, encryption algorithms. So, but I do want to use JSON Web Tokens in my Go applications. So how would I go about doing that? Well, Go loves JSON Web Tokens, and there are many well-tested and implemented libraries, and we at Auth0, we kind of looked at all of the different libraries, not just for Go, but other languages as well. And Go has some of the really, top-class open source implementations of the JSON Web Token standard. And here I'm just showing you a simple example using the JWT Go library. If I wanted to create and sign a token, it is really simple. I just import the library, declare which signing method I'm using, HS256 here, and then I map my claims. What do I want in that token? And here I'm just using the issue tag, my name, and my role. Finally, I sign the token with my secret that I'm not going to share here, and my token is good to go. And then the general rule of thumb is you should always try to, so like for demos, I use HS256 just because it's a lot easier to show how signing the tokens works. But if you're building a production-based application, then using an asymmetrical algorithm like RS256 is definitely preferred. And then the other thing that I wanted to point out with JSON Web Tokens is that they are signed but not encrypted. So once you sign a JSON Web Token, you get that really nasty looking hash. Anybody can decode this. I can copy this, put it in JWT.io, and it's going to tell me exactly what's in it. So it is not encrypted. It's not secure. There is another standard called JSON Web Encryption if you needed to encrypt the data. But for the most part, JSON Web Tokens, they're not encrypted. They're just signed against modification. So anyway, getting back to the presentation. So that was a really brief introduction to how JSON Web Tokens work, how we create them, how we validate them. The next part that I wanted to talk to you guys about is middleware and handlers in Go and how using JSON Web Tokens in your RESTful applications, at least how I use them and how I scaled my application, really well how it worked. So middleware in Go, I'm a hobby Go developer, so I'm not, I don't use it at my day job, but I do tinker with it every chance I get, and I do try to evangelize Go as much as I possibly can. And the one thing, a lot of my colleagues, they're Node.js developers, so whenever I try to show them Go, they're like, oh, middleware isn't as easy as it is in like Node.js Express. It's a little bit more difficult, and if you're using the standard library, chaining those functions isn't as clear and isn't as easy to see what's going on. So Gorilla gets another shout out tonight. The Gorilla Month library is what I use for managing all of my routes, and then the Negroni middleware for chaining all of my functions. So this gives me a really, really good framework for managing all of my routes, and then managing all of the middleware for each individual route. And my API, has 80, 90, 100 routes. So the way that I implemented this, rather than trying to do everything, in one giant file, I started off by creating a struct for my routes. And it really just has 4 properties: the method, which is the HTTP verb, get, post, put; the path, which is just the string for the endpoint; and then an array of Negroni middleware functions. So I could, if I just want to authenticate a request, I could add the middleware there. If I also want to check that the user should have permission because this endpoint, is highly protected, I can add as many functions as I want. And then finally, I have my handler, which implements the actual functionality of that endpoint. So my routes end up looking like this. It's just, one file that has, it's an array of the struct route, and I, declare the method, declare the path, pass in any middleware or no middleware at all. And for the middleware that I do want protected, like, say I'm building like a review aggregator, like, OpenCritic or Metacritic, I don't want just any client to be able to access, all of the reviews in my application. So I'll use my authenticated middleware, my JSON Web Token middleware, to ensure that the request that's coming in has an authorization token, has a valid JSON Web Token in the authorization header, and that it works and that I can validate it before giving them access to the resources. And then once I have all of my routes defined, and whether it's 10, 100, 500, I just have a simple loader that runs when the application is first booted. So again, I'm using Negroni as the chaining library for all of my middleware, load up the Gorilla Mux router, and then I load my routes. So what I do here is a simple for loop. So for each of those routes, I get its middleware and I append it to, so basically right here, so we have the Negroni handler middleware, which takes an array of Negroni functions. But the handler is an HTTP handler func. It's not a HTTP handler. So Negroni has this really, really helpful method called wrap, which basically wraps your HTTP handler func into an HTTP handler, so that I can append it to that array, and then I basically register all of those routes using the Negroni new method, and just pass in my array of middleware. So whether it's 1 or 5 or 100, they're all gonna load in that sequential order. Finally, there's always some global middleware that you're gonna want to apply to your applications. So in this example, I'm using gzip, and I want to make sure that my responses are as small as possible. So I'll apply that to all of the routes, whether they need to be authenticated or not. And then finally, I'll just return that router to my application, boot it up, and everything works. So the last thing I wanted to look at is one way to do the authenticated middleware and to verify that the JSON Web Token that's coming in is valid. And you would do this in a middleware. You wouldn't want to do it in each one of your routes individually. So middleware and really makes sense here. So I didn't include all of the error handling here just because it wouldn't fit on the slide. But the first thing I would check for is to make sure that I do have an authorization header in the incoming request and that it does contain a valid JSON Web Token. Once that's complete, I'm going to check and make sure that the signing method that I signed the token with, and the good thing about JSON Web Tokens is you don't have to sign all of them yourself. You can use a third-party service like Auth0 to generate your tokens. You can generate them at a different microservice. As long as you know the signing key, or if you have the public-private access to the keys, if you're using RS-256, then you're good to go. But you want to make sure that the signing algorithm matches what you're expecting. And then since I'm using HS256 here, I again pass in my, my secret, and this function, the go JWT package, is gonna parse the token and make sure that it's valid. And if it's valid, then we know that this is a token that we generated, a token that we trust, and we're going to let the user, go through. The other thing that I would do here is get all of the claims from that token, because now the token's been decrypted, it's been verified, and it works. So I'm going to get all of the claims from that token that I care about, and the one that I'll probably care about the most is the role of the user that's, or the role of the client that's coming into my application. So if they're making a request and they're not an admin, I'm not going to give them access to my revenue reports or whatever resource they're requesting. So using the really great context package, I'll just pass into the next middleware the role that the user has, the role that the user is giving me from their JSON Web Token. And then I'll have another, say this is authenticated. I might have an authorized middleware that's going to take in what the endpoint is requesting, or what level of permission, and then depending on what I'm passed from that token, if the user does have that permission or a higher one, I will go down to the actual handler and complete the request. Otherwise, I'm going to short circuit it and respond with forbidden. So key takeaways that I had, building a Golang API is that Go is really awesome for building HTTP APIs. One of the funnest programming languages that I've had an opportunity to work in, standard library, bar none. And then using the Gorilla Mux and the Negroni middleware management really makes for a really powerful routing and middleware management combo. So I can register new routes just in that one file, just in my routes file, and they'll get loaded automatically. All of my middleware will be taken care of. I don't have to worry about how my application is, where I'm putting my code. I have a well-defined structure of how it's going to work and where everything is. And then finally, JSON Web Tokens allow me to painlessly secure the API that I'm building. I can either sign my tokens from my Go application or use a third-party service, and then very easily, thanks to the very powerful open source libraries that the community has worked on, secure my HTTP APIs. And that's really all I had for this brief demo. If you guys do have any questions on JSON Web Tokens or anything, I can make this code open source. It's kind of like internal for right now, but I'd be happy to release this loader for you guys if you're interested in using it.
Any questions? Any questions? I'll come back.
I don't know if this applies to your scenario, but how do you handle cases where you either delete a user or delete a permission for a user?
Okay, sure. So if you guys haven't worked with JSON Web Tokens before, they're basically stateless. So once you create a JSON Web Token, it's valid until its expiration time expires. So the question was, say that I join a company and they give me admin access and I log in, and then they're like, oh, you don't know what you're talking about, so they fire me that same day, and I'm still logged in. And that JSON Web Token, how are they going to revoke it? Well, you can. There's a couple different ways you can do it. So one of them is to create a blacklist. So again, you could do it in a Negroni middleware, where once you validate a token, you can send it to an external database. This is going to make your token stateful, but it's going to allow you the opportunity to blacklist tokens. And I guess maintaining a blacklist of tokens is much faster and much smaller than registering every individual token that you create in your database. And then also, the other thing you can do is make the expiration time on your token really, really short and use refresh tokens every now and then. So this is going to allow you to, again, keep the stateless nature of JSON Web Tokens while still giving you a little bit more security.
When you start using JWTs, you run into a balance between how much information you put in the token versus putting an ID that you then look up on the other side. And is there rules of thumb about how much do you cram in if you have a lot of rights? piling all those rights into the token. It takes time to transmit versus the time you take on the back end to do a lookup to the database. So you can skip some database lookups if you pile a bunch of stuff in the token, but then you're moving the token around.
So that's a really good question, and so there are a few considerations to make. So one of them is where you're going to store your JSON Web Token. If you're going to put a whole bunch of data in it, you can't store your token in a cookie because they're limited to 4 kilobytes of storage, and every claim you make is going to make your token bigger and bigger. So I guess the general rule of thumb is to put as little information as you can in your token while still being able to meet all of your needs. So if you are using like a session ID, you just have an ID and you can't really store anything else in there, so you have to do that database lookup each time. But with the JSON Web Token, if you put a couple of different claims in there, 5, 6, 7, the data it's going to be much bigger than a cookie, than a session ID, but it's going to save you a lot of time on the other hand doing the lookups.